Coming up on SpaceTime, scientists observed the flattest explosion ever seen in space. Was plate tectonics occurring when life first formed on Earth? And development continues on Europe's space rider spaceplane. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have just witnessed what they're calling the flattest explosion ever seen in space. The blast, some 180 million light-years away, challenges science's current understanding of explosions in space, which are almost always spherical, because this one looked really as flat as a disk. The explosion was that of an extremely rare fast blue optical transient, or FBOT. Only 4 other fast blue optical transient FBOTs have ever been seen, and scientists really don't know how they occur or what they are, but they're hoping this discovery might help solve at least part of that problem. Potential explanation for the flatness of this explosion is that the star itself, which blew up, may have been surrounded by a dense disk, or it may have been some sort of failed supernova. And this was a big explosion, about the size of our entire solar system. Fast blue optical transients are still fairly new. The first wasn't discovered until 2018, and it was given the nickname the Cow. The new study has been published in the monthly notices of the Royal Astronomical Society. Its lead author, Justin Maund from the University of Sheffield, says very little is known about fast blue optical transient explosions. They just don't behave like exploding stars should. They're too bright and they evolve too quickly. He says, put simply, they're weird, and this new observation makes them even weirder. Now, there are a few potential explanations. The stars involved may have created a thick disk of dust before they died, or they could be some sort of failed supernova, where the star's core collapses into a black hole or neutron star, which then eats the rest of the star. What we now know for sure is that the levels of asymmetry recorded are a key part of understanding these mysterious explosions, and it challenges preconceptions of how stars might explode in the universe. Scientists made their discovery after spotting a flash of polarized light completely by chance. They were able to measure the polarization of the blast using the astronomical equivalent of Polaroid sunglasses using the Liverpool telescope located on La Palma. By measuring the polarization, it allowed astronomers to measure the shape of the explosion, effectively seeing something the size of our solar system, but in a galaxy 180 million light-years away. They were then able to use that data to reconstruct a three-dimensional shape of the explosion, and were even able to map the edges of the blast, allowing them to see how flat it was. The authors now plan to undertake a new survey of their blast using the International Vera Rubin Observatory in Chile, which should help them discover more fast blue optical transients in the hope of better understanding these mysteries of the universe. This is SpaceTime. Still to come, were plate tectonics occurring when the first life formed on Earth? And construction underway on Europe's first space rider spaceplane. All that and more still to come on SpaceTime. A new study claims that plate tectonics was already active on Earth 4.2 billion years ago, at a time when the first life is believed to have started forming. The Earth is a dynamic and constantly changing planet. From the formation of mountains and oceans to the eruption of volcanoes, the surface of the planet is constantly in a state of flux. At the heart of these changes lies the powerful force of plate tectonics, the constant movement of the Earth's crustal plates. This fundamental convection process has shaped the current topography of the planet and continues to play a role in the Earth's future. But what was plate tectonic activity like early in the Earth's history? In fact, was the process even occurring during the time when life is first thought to have evolved on the planet? The study's lead author, Widju Chowdhury from the University of Rochester, says the dynamic tectonic nature of the modern Earth is one of the reasons why life exists today, and exploring the geodynamics and lithological diversity of the early Earth could lead to revelations about how life first began. The new findings, reported in the journal Nature Communications, outlines how scientists use small zircon crystals to unlock information about magmas and plate tectonic activity in early Earth. The research provides chemical evidence that plate tectonics was mostly likely to have already been occurring more than 4.2 billion years ago. That's the time when life is thought to have first formed on the planet. Plate tectonics on modern Earth is extremely important because it's the dominant mechanism for the creation and destruction of the Earth's crust. And the Earth's the only known planet to have a mobile upper crust which is cyclically destroyed and recreated. It's an important process because it delivers a constant fresh supply of crucial elements, such as iron and magnesium, from deep inside the planet's interior up to its surface. And it controls Earth's water and carbon cycles. Even our atmosphere is dependent on it. But more importantly for geologists, plate tectonics melts and mixes rocks to create magmas with specific chemical makeups, depending on the rocks involved and the location where the destruction occurred. The chemical makeup of the magmas can therefore indicate the type of tectonics that created it. Chowdhury and colleagues conducted their research using zircons, tiny crystals in rocks that are like small time capsules. That's because zircons contain trace amounts of specific chemical elements which are locked into the crystals at the time the crystals first formed. By comparing different ratios of different elements, scientists know exactly when in geologic history that zircon was created. They can then work backwards, with the zircons revealing information about the chemical makeup of the parent magmas from which the zircons crystallized. Researchers then use this information about the magmas to reconstruct the physical and chemical environment and to infer plate tectonic styles of the early Earth during the time when the zircons were formed. Now, in this case, the zircons were around 3.8 to 4.2 billion years old. According to Chowdhury, most researchers infer information about the early Earth using zircons to create probabilistic models to present different tectonic scenarios. But here, the authors went a step further to describe not only the zircons, but also the parent magmas. Chowdhury says parent magmas are much more direct and reliable because they're closer to the source, the actual tectonic style. This study describes the silicon and oxygen isotopic content of the zircons and the trace element content of the parent magmas, none of which had been combined and presented before. The authors found chemical similarities between the early Earth magmas and modern magmas created at tectonically active plate boundaries, such as the Cascade and Aleutian Island chains, areas around Japan, and in the Andes Mountains. All this suggests tectonic continuity from ancient to modern times. In other words, the study shows that billions of years ago, the Earth might have operated pretty well the same way it does today. Chowdhury says the researchers couldn't determine whether life existed when plate tectonics began, so neither life nor plate tectonics have an accurate starting date yet. But the new data does provide chemical evidence suggesting that plate tectonics could have already been occurring more than 4.2 billion years ago. And when you think about it, that's less than 500 million years after our planet first formed 4.6 billion years ago. This is SpaceTime. Still to come, work continues on Europe's new Space Rider spaceplane. And later in the science report, new satellite data warns that global water cycle extremes such as droughts and floods are on the increase. All that and more still to come on SpaceTime. Engineers across Europe are continuing work on the European Space Agency's new Space Rider spaceplane. The Space Rider is based on ESA's intermediate experimental vehicle, the IXV, which flew back in 2015. The 10-metre-long, 2,430-kilogram Space Rider spacecraft will launch aboard a Vega C rocket carrying payloads of up to 800 kilograms into low Earth orbit. It'll be Europe's first reusable space transportation vehicle. It's designed to remain in orbit for months at a time, serving as a space microgravity laboratory for chemical, biological, physics and material sciences experiments, using a modified version of the Vega C's Avoom Plus upper stage as a service module, providing power, attitude control and deorbital capabilities. Spacerider's ability to change its orbital altitude and inclination means the spacecraft will be able to undertake a range of different types of missions beyond scientific experiments, including Earth observation, telecommunications, and robotic exploration. And once the mission's over, Spacerider will re-enter the Earth's atmosphere using its lifting body designed to burn off speed. It'll then deploy a giant parasail and glide to a conventional runway landing. Afterwards, it'll be refurbished and re-equipped with new payloads for its next flight. The Spacerider is designed to be reused at least 6 times, with a turnaround between missions of less than 6 months. The maiden flight for the new spacecraft has been tentatively slated for December 2024. ESA's Director of Space Transportation, Daniel Neuenschwender, says Spacerider will provide the European Space Agency with a unique capability for scientific research in a wide range of fields.
It's a fact that today Europe does not have this capacity. It is also a fact that Europe will have it tomorrow. And in fact, at ESA, we had already a technology demonstration of a re-entry on Earth, which took place a few years ago in an experimental vehicle called IXV. And based on this experience, which was highly successful and launched by Vega, by the way, we are now developing Spacerider. During low Earth orbit operation in microgravity, the vehicle can turn, maneuver according to the mission it has. And then, at the moment in time you start the re-entry on Earth, in fact, you have a dedicated angle of attack. You start to enter into the atmosphere, and this is what we call a lifting body, meaning there are no plane type of structures. It's just the body which has a certain angle of attack, enters into the upper parts of the atmosphere at high speed. We call it hypersonic, and then the speed is decreased through the drag, and when it starts to become subsonic, you have lowered significantly the speed, and once you have reached a certain level you can deploy a parafoil, and once with the parafoil deployed you can have a precision landing on a runway somewhere in Europe. We do a call for opportunities, and we will have different flight opportunities planned, for example in microgravity research. So if you are coming from a university, that's for sure an opportunity, like in material sciences or pharmaceutical field, biological field at large scale. Second, we will work on commercial opportunities, and here we have already quite good exchanges, again with the pharmaceutical industry. And we will look for further in-orbit validation and demonstration of technologies which have to be tested and qualified in space before they go on big and costly missions.
That's Daniel Neuenschwender, ESA's Director of Space Transportation. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. New satellite data warns that global water cycle extremes such as droughts and floods are increasing. The findings, reported in the journal Nature, show a significant increase in water cycle intensity between 2002 and 2021. The authors say there was an excess in intense drought and extreme weather events during 2015 to 2021, which were also the hottest 7 years on record. The team found that Australia's Millennium Drought actually appeared as 3 smaller events in the data rather than one large singular event, and would have ranked as the 14th most intense drought. And that drought finally broke in 2012, ended by what was shown to be the 3rd most intense wet event recorded during the observation period. A new study has confirmed that despite what you think, people usually misremember events within seconds of it happening, often reshaping their memories in order to fit their expectations. The findings, reported in the journal PLOS ONE, looked at 45 participants who were shown a series of real or pseudo letters. Scientists found that within seconds after the display disappeared, memory errors started to crop up. Yet the participants' confidence in what they thought they saw and remembered increased substantially. Researchers found that errors made with high confidence mainly occurred for the pseudo to real letter memories. Much less often for the real to pseudo letter memories, which researchers say is because of our pre-existing expectations of what letters should look like. It's been suggested that scientific and medical journals need to acquire proof of data collection because the ChatGPT AI makes it too easy to fabricate non-existent data. The warnings, reported in the journal Patents, follows a test in which the AI-based language model chatbot was asked to write an abstract about rheumatoid arthritis using data up to the year 2020. Now, the study's authors knew that the chatbot really only had data up until 2019. Still, ChatGPT provided the abstract they asked for without question, and also claimed that it had used data from a database known to be protected from public view, which actually implies that the data was fabricated. The authors also successfully asked the artificial intelligence to reword the conclusion to support a particular claim. The resulting abstract showed how easy it was for ChatGPT to fabricate a paper. And journal publishers now need to be aware of the possibilities and screen for artificial intelligence in the same way that they currently screen for plagiarism. Australia has joined the United States, the European Union, Great Britain and New Zealand in banning the social media app TikTok from all government devices. As we first reported more than 2 years ago on this program, TikTok was being used by China's communist government to monitor the activities of people by recording their keystrokes, switching on their devices' microphones and cameras, copying their address books, private notes and messages, and even tracking their location and online history. Australia's Attorney General Mark Dreyfus says he authorised the mandatory ban on TikTok as a protective security direction, because the app possesses significant security and privacy risks for non-corporate Commonwealth entities arising from excessive collection of user data and exposure to extrajudicial directions from a foreign government that conflicts with Australian law. With the details, we're joined by technology editor Alex Zaharov-Reutt from ity.com.
The keystrokes, the microphones and the cameras, I mean, any program on your device, your camera even, your Facebook, TikTok, it needs those permissions. Otherwise, the app can't do anything. It can't accept anything you type in the keyboard. It can't record anything, take any photos. But if you look in the nutrition label on the app stores for what TikTok can do, it once it identifies your browsing history, your financial information, all sorts of things. There's a whole stack of different things, but every single app of a social media flavor requires or wants that information. Of course, the worry is that in theory, and some people would say you cannot, but in theory you can trust the US companies and the US government to not want to put you into slavery and put you into a re-education camp. And the Chinese government because the Chinese government has ordered every Chinese company to give it whatever information it requests and deny that it's given that information out. You cannot then trust any Chinese company with its guarantees that it's not going to give that information to the government or to keep it private. And so really, instead of just banning things outright, because this is not banning citizens from doing it, this is not stopping politicians who have already admitted to having used burner phones, phones that are not linked in any way to their government address, to still be able to send messages out to their Twitter followings. I mean, they have to rebuild them if they did indeed use their government email addresses, as some have. I mean, some politicians have said, yeah, we're going to switch it off. Others have said, no, I'm going to keep going. But, they must be using private accounts. But, we need regulations on what these apps can and cannot take from our phones. If the app doesn't need our browsing history, then it should not be having any access to it. If the app doesn't need financial info because we're not paying for anything, then it shouldn't have access to it. We need to set in writing what apps can take and what they can't. And the companies that write the apps need to give the source code to various governments and make available for individuals to see whether that information is being surreptitiously taken from us. And also you have to make sure that you're not downloading the apps from third-party app stores, which do not get the same level of scrutiny that they supposedly do from the App Store and the Google Play Store, because nothing stops a third-party app being hacked by anybody to get this information from your phone through some jailbreak, through something, because normally apps have sandboxes sandboxes, and they can only play in those sandboxes that can't get access. But when you're dealing with an app that's been hacked, basically, and available from a third-party store, then, not even the company themselves. So, look, there's a ban. It's taken a long time for the government in Australia to do it. It already happened overseas. It's not banning TikTok outright. And, TikTok's going to have to either sell its source code to some US company or some foreign company. Otherwise, it's just going to end up being banned completely. And we have alternatives in Facebook and YouTube and Twitter and other things that from Western companies that, in theory, in inverted commas, can be trusted more, which can offer the same sort of functionality in terms of the algorithm and how information is, the videos are offered up to you. And even Twitter has made its algorithm now available on GitHub for anybody to see. So there's going to be this whole shift towards privacy, and it's been a long time coming, but it's going to get louder and louder, and we're going to have to figure out whether we can trust the people offering private apps. But we either are going to go to a world where we can have privacy, or there'll just be no privacy, and you're in a communist society where everything belongs to everybody, including your life and everything you're interested in, which would be a horrible, terrible thing.
That's Alex Zaharov-Reut from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.